Okay, so first of all, you need to, if you want to go the Octave route, you need to download Octave. Okay, so that will do. So download, and I'm not going to do that because I already downloaded Octave. So download whatever version, whatever OS you're using, Mac, Linux, or Windows. Once you download it, that's the shortcut. Now it turns out this is a shortcut created by Windows, and this is the shortcut which I dropped down. There's a difference. If you, and I had this where I opened it and I was like, this is not how Octave looks. It turns out that this shortcut, the GUI, is the one you open, which pops up this. And so be mindful of that. That is, you need the right shortcut, otherwise you'll not get the GUI. But this is what you're looking for. It looks exactly like, well, similar to MATLAB. Okay, so there is a command window where you can type things. So this is like a calculator where you type things and you get output feedback immediately, but then there's something called script. So we'll first go through the basics of the command window, just play with it, and then we'll go to scripts. And I trust we'll be done fairly. It's going to be a fairly short lecture. Okay, so what you see here is the command window. That's like the place where you can use it as a calculator. There is this is the path, so it's users pranav. This is the workspace. Anything you type shows up there. Okay, so you can, it sort of keeps track of all the variables you've created, generated, so you can reuse them. So for example, I could write 2 times a. That's fine because it's already saved. Then we have the command history, and then there's the editor, which I'll be talking in just a bit. Okay, so this is sort of a refresher. Think of this like a calculator. As I said, you can start writing things and then just using it like a calculator. The good thing is that it stores all these things. By the way, is the font big enough? Can the guys behind see? Okay, perfect. Okay, now what happens is when I type c equals a plus b, it actually prints c equals 3. But if you type it this way, a plus b with a semicolon, it doesn't print. So suppressing the printing is done by putting the semicolon in place. What Octave does and MATLAB is basically, MATLAB is matrix laboratory. Same thing. Octave is the same thing. Anything you write down is a matrix. So when I wrote a, I got a size. If you write the size, you get the size of size of a, and that's 1 by 1. It means that it's interpreted as a matrix of rows 1 and column 1 column, right? So we can now, given that, we can create a vector. This is also stored as a array. So if you do size d, so expecting it to be 1 row and 3 columns, and that's what it is, 1, 3. Okay. Now sometimes you're interested in a single column and multiple rows. So if you want to convert that to a column, then you just do d transpose, and that's a column. So if you do size, you get 3, 1. Now you don't have to take notes. By the way, I'm going to post all this. This program will be on Blackboard also. The video will be on Blackboard, and I think I'm going pretty fast, so it might be hard to take notes. So then, if you want to define it from scratch, a column vector, you just say 1, 2, 3 with the semicolon as I've shown there. And so this is now a column vector. Okay, there's always help available. I think if you type help size, it tells you more details on. I'm not able to scroll up. This looks like a bug. Yeah, so I'm not able to scroll up, and I think this is a bug, and this is kind of expected because this is a free software, so there would be bugs. Normally, if you do this in MATLAB, it actually lets you scroll up. But the other way to find help is to go online, which I highly recommend, and just say help Octave size. Okay, so then the same thing which I saw there will probably be here. Exactly the same thing. Okay, so that's another way of getting help. Okay, and So let's clear the screen, clear in CLC. You can also use random number generators. So 3, 3, this gives you a random number uh, with size rows 3, columns 3, and then these numbers are basically 0 to 1. So you'll not see anything greater than 1 or less than 0. Okay, there are nice inbuilt functions. So if you want the inverse of A, which is just, okay. So if you want to check that, clearly if you multiply A with its inverse, you should get the identity. And that's the identity, right? Don't be fooled by the 17s and it's physically 0, close to 0 on the off diagonal elements. Okay, so then if you want to do plots, and we'll do a lot of plots in this course. You know what, let me just use a script for this. So we'll stop here with this is just introduction to the command window. Now, what you do here, unfortunately, is not stored anywhere. So if you want to rerun some of this code, you have to either store the history, which I think is cumbersome, but it'd be beneficial if you can store whatever you write so that you can just run it anytime. And all the things we'll do will probably be through scripts so that once it's saved, you can run it with new inputs and generate whatever outputs you want. So for that, we will use an editor. So whatever we type here, we'll save it. And before we get there, I just don't like this view where you have the editor, like say if I write something here, the output of this will be produced in the command window and I have to skip back and forth. Let me just start doing the plot thing here, and then we'll see what happens. Maybe we'll improve the workflow from there. So here's my first script, which I'll just use to make a plot. Okay. So let's plot sine of x, a simple function. Okay, so linspace is a command which generates linearly spaced numbers from 0 to 6, and there'll be 100 bins. So it'll be 101 number. I think it's 101 numbers. So I don't want it to print the output, so I'll suppress it by putting a semicolon. Y equals sine of x. And now, before running it, I want to save it. Let me save it. Just save it on the desktop. We call that test1.m. Okay. And now let's run it. So this is the code to run it. I would always recommend change directory so that wherever I saved it becomes the directory, which is here you can see users pranav desktop. That's where I saved it. And now you see that there is there's something generated, but let me just do it this way and run this. Okay, now I'm expecting it to print y equals sine x. To see y equals sine x, I need to go here. Okay, that's basically the output. So every time I need to go back and forth to check, and that's not good. So what I'm going to do is I'm going to show you how to move the command window so you can see the editor and the command window in the same place so you can see the output. So I think I've linked a video for this, but you essentially get the toolbar off, then go to command window. I think you can move it. Okay, and now we don't. What we want here is the editor. And so now when we run this, okay, so you see that the output was produced in the command window. You don't have to remember this. I've seen the video, but I've posted a link on how to do that. It's kind of a little bit tricky. Okay, now we got that. Let's do a plot. That's what we go after. Plot x comma y, and on that. Okay, so that's the plot of x comma y. You can change the line type and also the color. So I made it red, and let's say put cross. So it'll be instead of line, it'll be a crosses. Okay, now so it's the problem. So you don't see the figure anymore. It's because there was a figure. It was still there. It was refreshed. It was behind the. So it's probably here somewhere, right? So if you want to avoid this, what I recommend doing is this. I always start my coding with the command. I put 3 things there. CLC. CLC will clear the command window. I put clear all. Clear all will clear all the variables in the workspace, so you can start fresh. And then I do close all. Close all will close all the figure windows. So if you do run this now, There it is. Okay, that thing popping up there is probably because there's another screen here, so it thinks there's something about the resolution. That's why it pops it down. But that's with red. Now you could add a label. Okay, and then you can put a title for plot of sine of x, and then run it. Okay, so it's very small. There's a way to do that. I think you need to say font size. Let's say 16. Okay, so that's so how did I know that? Well, I went to before the class. I went to here and I just said plot Octave. No, sorry, title Octave. How to increase size. Okay, so there is, you can watch that. There's probably some help. A string. String is whatever the string plot of, but then there is property and you can give a value. So we need to figure out what property we want. Hey, it's not much here. Octave, title, properties. Okay. Here we have, so this is probably some help from Octave. So maybe there's an example, and that's a good way. Often I try to copy paste an example and then edit the example. So here you can see they actually have given the customization options. Box out, right, left, X label. No, these are something else. Okay, I'm trying to figure out how to get the properties. What are the properties? Maybe searching property. Okay, no luck there. So if this was MATLAB, you would have more readily help available. It just seems like it's not available here. So you need to sort of dig around and find it. Many times it's about posting a question, just a question on Google. How do I edit the font size for title in Octave or MATLAB? And then there's typically this many questions are answered on Stack Exchange, which is like this place where people post coding issues and they're resolved. Yeah, question. Yes, that's a good idea. So you could actually use the MATLAB documentation, which we can try. MATLAB title property. Octave is buggy, yes. That's free software for you. Comes at a price. So sometimes also searching MATLAB forums will help you. So I think that here, no, this doesn't give you font size. I mean, I guess if you read it, you'll probably get it, how to find. But yeah, you can obviously refer to MATLAB because what the people in Octave have done is they've tried to emulate MATLAB as close as possible. Okay, where were we? Okay, one important thing which you would need in this course is the ability to output the plots, right? You want to save the plots so you can submit it to for the homework. And so that can be done in the following way. So I have a figure now. I'm going to save it. What you do is you write print. We need to give this figure a name. So this is figure 1. And let's call it H. It's like the handle which goes with the figure 1. All you say is H and then give it a name. Sine X versus X. Okay. So what it does is it takes this H, object H, which is figure 1, and then it just produces the figure sin x versus x, and I think I want a PDF. So if we run this on the back end, if I go to the desktop, that's the place where I had the what do you call the file. You should see it here.
Users.
Oh, it's through users, not here. So I need to users. There it is, desktop. That's my file, test1.m. I'm trying to find sin x. Oh, it's not there. I think this thing is crashed. Okay. Yeah, that's why maybe do not create one. Popped up. Oh, there it is. Nothing. Okay. Let's open it again. Okay.
Maybe we will need to find it.
No, you don't have to buy MATLAB. This is the first time it has crashed on me. It actually did not save anything. So toolbar. I've never had a problem. I've prepared the whole course in Octave, so I can vouch for it. And this is my first time using it, but I'm not terribly displeased with it. It's a good package.
Maybe because you're on the series and also expensive.
Yeah, it might be something else, right? Okay, so let me just drop that file. Okay, run it again. So it's important here that you do change directory, otherwise it'll populate somewhere else. Seems like this is a bug with my way of printing that PDF. It gets hung here. So it's probably this command I checked on my Mac, it works. Seems like there's a bug on Windows. So the other way to save this is actually you can do file save as PDF, which is the other way. So it won't allow me. So it's probably something to do with Octave on Windows, the way it's set up. Okay, it's crashed again. So I would not attempt to do that. But you can always go to File, and when it puts the plot, just to File, Save As, and you can save it whatever you want. Okay, let's do one more example, and we should be done. Okay, I'll show a very benign example of how do you create an array and just sum all the elements of an array. Very simple example. There's inbuilt functionality, but we'll write a function to do that, and that will get you started on functions, which I think is the other important thing you need to know. As I said, I always do CLC, clear all. I'm not going to have any figures, so I don't need close all. Let me save this as right on the desktop as test2. Okay. I'm going to generate a random vector with 5 elements. You can run this to see what it generates. So change directory. So those are the randomly generated numbers. Now, if I want to sum the elements, okay, I'm going to show you different ways of summing elements. Comments are this way, or you can also put a hash, I think. So summing method 1. Okay, how do you sum? Well, you can just say sum of A. That should work. You suppress this. Yeah, so it printed a sum, whatever it is. We'll try to emulate the same thing we're doing our own method of doing it. So method 2. So this is a standard way to do this is to create a total sum, which is a variable which keep track of the running sum, and I'll cycle through the whole length of the array A. So length A. So A has 5 elements, so it'll go 5 times. So this will be 1 colon 5, which will go 1, 2, 3, 4, 5. So then I do total sum equals total sum plus A of I. And I need to say end. That's how we close a for loop. And now what I'm going to do is I'm going to say disp total. Yeah, so you see that it's this one. So ignore that. Let me just run this again. Okay, you see that 2.725 using the sum A. We also got display total sum as the same answer. Okay. Now here's the third method, which is what is about writing a function which will do things for you, so you don't have to keep writing total sum. So if you have like 5 different arrays, each time I need to write, so say 5 arrays, I need to sum them. I need to write this for loop 5 times, right? To avoid that, I'll have to create a function. So here is the third way to do it, method 3, where I'll create a function called mySum, and I'll pass A, and it'll do the magic for me. So let's write this function. So that's my function. Its input arguments is A, and it should return, remember, it should return the sum. So I'll use another script file. Now this is a function. It should go by the name function. The name of the function is mySum. The inputs to it is, you can put, let's say, array. You can call it anything you want. This is a local variable. It doesn't have to have the same name as the one which you used. Now it should return total sum, right? Something is not right. So this is right. My bad, yeah. This looks good. So this is a syntax. So the inputs to the function, the outputs, and now all I need to do is copy paste some of this code. Remember, this is called array, and this is called, and then I don't need to display it. This total sum is kept track, it's returned, so I don't have to. Now, one thing you want to remember is you want to call this function as mySum. It's actually automatically taken as my underscore sum. If you don't write it as mySum, Octave will have a hard time getting that function. Okay, so here we are. So we can go test2 and run this. And we see it's 1.867 by all 3 methods. Now, the advantage of having that A made that way is because you could just do 1, 100, and then just say mySum P. And then if you had another one, rand 1, 54, so 54 elements, you can just say mySum C. So it just helps you, it makes your life easy by not having to, I should suppress this, not having to write that for loop again and again. So it just gives you the sum. So this was not the best introduction. It's just pretty fast, but a lot of it is about asking the question, how do I do this to Google, getting a chunk of code, copy pasting it, running it, improving it. And that's, I do it all the time. Even the simplest functions, I copy paste code, improve it. Absolutely fine. It's not frowned upon.